Hello, students. You are welcome to Wanies Academy. So, we're starting a new topic today in chemistry, and the topic is mass and moles. So, I'll say that again for clarity. Mass and mole. That's the topic we are having today in chemistry class. So, the aim stated for this class is to explain the relationship between mass and mole. So, I also have some objectives outlined for this class. So, the objectives are as follows. At the end of the class, the student should be able to 1. Define mass, 2. Define mole, then 3. Understand the relationship between the mass and mole. All right, so I haven't stated the objectives for this class. I commence my class in earnest. So the first subtopic we'll be looking at is mass. Now, when we say mass, what are we referring to? Now, the mass of a substance in chemistry can be defined as the amount or the quantity of matter present in a given sample of that substance. So in other words, mass can be defined as the quantity of matter in a body. And the SI unit for measurement of mass is kilogram. So we usually measure mass in kilogram. However, it has smaller units, right? The smaller unit of mass is grams as well as a milligram. However, in chemistry, the quantity of matter in a body called mass is usually measured in grams. It's usually measured in grams. So take note of that. Then also, there's an instrument with which the mass of your body is usually measured. Now, the mass of a body is measured with an instrument called chemical balance or beam balance. So I haven't defined what mass is and stated the unit with which you measure mass and stated the instrument with which you measure mass. So we go to the next subtopic, which is mole. So we are going to the next subtopic, mole. Now, when we say mole, what do we mean? What does it entail? Now, usually, during chemical reaction, particles are usually involved in chemical reactions in chemistry. Now, these particles can either be atoms, molecules, or ions. So when particles of reacting substances, right, undertake chemical reaction, now these particles are either atoms, molecules, or ions. So generally, chemical reactions in chemistry entails particles partaking in such reactions. Now, the issue here is these particles mentioned, atoms, molecules, or ions, they are extremely small. They are very infinitesimal, very, very small in nature. Therefore, when we carry out chemical reactions in chemistry, we work with large quantities of particles, right, so as to overcome the problem of the small nature, right, the smallness of the particles. So usually we work with large quantities of particles when chemical reactions are carried out in chemistry. Now, therefore, there is a need for us to have a unit that contains a specified number of particles of substance in a given sample of a substance. So we have a unit, or a unit is needed that will contain a specified number of particles, right, that is needed during chemical reaction. Now, such a quantitative unit containing a designated or specified number of particles in chemistry is referred to as a mole. Now, so the question then is, what is 1 mole? How do we define a mole in chemistry? Now, 1 mole, right, can be defined as the amount of a substance that contains as many as elementary entities as there are in exactly 12 grams of the carbon-12 isotope. So let me say that again. 1 mole or a mole of a substance can be defined as the amount of that substance that contains as many as elementary entities as they are in exactly 12 grams of the carbon-12 isotope. Now, usually there's a symbol with which we denote a mole, right? So usually mole is denoted with the symbol N, right? Then mass is denoted with the symbol N, that is small letter N. So I'm still coming to that. So now remember I just said 1 mole is the amount of a substance that contains as many as elementary entities as they are in exactly 12 grams of the carbon-12. Now, through careful experimental work and observation, it has been discovered that 1 mole of any substance is equivalent to or is equal to a constant, and that constant is called the Avogadro's constant. So now we can put that in writing by saying 1 mole of a substance, so a mole of a substance is equals to a constant that we'll call the Avogadro's constant, right? from the name of an Italian chemist called Avogadro. So 1 mole is equals to a constant referred to as the Avogadro's constant. So a mole is equals to that constant. So 1 mole equals to, so 1 mole is equals to the Avogadro's constant. Avogadro's constant. So and this Avogadro's constant is known to have a numerical value. So there's a numerical value associated with this constant called the Avogadro's constant. So Avogadro. So 1 mole is equals to the constant called the Avogadro's constant. So Avogadro's constant. So take note of that. So Avogadro's constant. Avogadro's constant. So now this Avogadro's constant has a numerical value, right? So 1 mole is equal to the Avogadro's constant. Avogadro's constant. Guys, we have A. All right. So now the numerical value of the Avogadro's constant is giving us 6.02. So that is the numerical value, right? So the value numerically, so 6.02 times 10 raised to the power of 23. So 6.02 times 10 raised to the power of 23 particles, right? So where the particle can be atom, molecule, or ions, right? So 1 mole is equals to the Avogadro's constant. And the numerical value of this Avogadro's constant is 6.02 times 10 raised to the power of 23 particles, right? So that means 1 mole of any substance will contain the Avogadro's constant, which is equal to 6.02 times 10 raised to the power of 23 particles. For example, 1 mole of oxygen contains 6.02 times 10 raised to the power of 23 oxygen atoms or molecules or ions. That is what that means or entails, right? So remember, we represent or denote our mole with small letter n. So take note of that. All right. Now, having stated this, now let's go to the relationship existing between mole and mass, right? So the relationship existing between mass and mole, or mole and mass. Now, the relationship existing between mole and mass is expressed using a parameter called molar mass. So the mathematical relationship that exists between mass and mole, right, is connected by a parameter, by a quantity called molar mass. And molar mass is defined as the mass in grams of 1 mole of a substance. Now, we define the molar mass of a substance as the mass in grams of 1 mole of a substance. Now, usually, there's a mathematical relationship that exists between mole, mass, and molar mass. Now, this mathematical relationship is given by an equation that goes thus. So there's an equation connecting these quantities together. So we have mole, right? Mole. Now, which I've told you, the symbol for mole is N, small letter N. So we have that mole is equal to our mass, right? Which of course is denoted by small letter n. So mass is denoted by small letter n. So take note of that. All right. So mass denoted by small letter m. So then all divided by molar mass. So divided by molar mass. So divided by molar mass. So it means that molar mass, right, connects the mole of a substance as well as its mass. So the unit of molar mass is grams per mole. So the unit of molar mass is usually given as gram per mole. All right, so in symbol, so if you are to denote all this, right, symbolically, so we want to denote this equation symbolically. So mole is denoted with letter N. So we have that N equals to mass. So mass is denoted with small letter M, just the way we denoted N mole with small letter N. Then molar mass is denoted with capitalized N, that is capital letter N. So in essence, mole equals to mass over molar mass, right? So take note of that. Then now from this equation, we can deduce the formula for calculating the mass of a substance. So all you need to do is just cross multiply. So on cross multiplying this, we would have that the mass of a substance, mass M, the small letter m, is equal to the mole of the substance, small letter n, times the molar mass, the big letter M, capitalized M. So that means mathematically mass equals to mole times molar mass. All right, so there goes the relationship that exists between mass and mole. All right, now let's take some solved problems, questions to illustrate this relationship existing between mass and mole. All right, now let's take a close look at a solved problem to make this clearer for us to understand. Now, example 1, what is the mass of 0.250 moles of zinc? So that's what you're looking at. What is the mass of 0.250 moles of zinc? All right, so now let's quickly attempt that question. Now, mass is unknown. The unknown parameter you are interested in here there to solve is mass. So mass is unknown, small letter m. So we denote that with a question mark, indicating that it's unknown. Then mole was given 0.250 mole. So mole is denoted with small letter m. So 0.250 mole. So we have 0.250 mole. So as the value they give us for mole, 0.250 mole, which is the same thing as 0.25, right? Mathematically. So the unit of mole is MOL. So remove the E in its spelling. So that stands as the unit of mole. Then now, the relative atomic mass of zinc, right, Zn, is 65 in the periodic table. So the relative atomic mass of zinc, transition metal, Zn, is given as 65. So therefore, the molar mass of zinc must therefore be 65 gram per mole, right? So now, substituting this into the equation where we have that mole is equal to mass over molar mass. I stated this relationship some minutes ago. Mole equals to mass over molar mass. So making mass the subject of formula, small m, now that gives us mass equals to mole times molar mass. So mole times molar mass, as you can see here. So if you have to cross multiply in that equation above, right? Let me delete this up so as to substitute the values quickly. So mass is what we are looking for. Since the relative atomic mass of zinc is 65, and the molar mass therefore will be 65 as well. All right, so let's substitute the values. All right, now therefore we have that mass, small letter m, is equals to mole, right? So the mole was given as 0.250. So that was the parameter we are given for the mole. So mole equals to 0.250 times the molar mass, which is 65. So when you multiply 0.250, right, by 65, that would definitely give us 16.25 grams. So remember I told that the mass of a substance is usually measured in grams in chemistry. So though the SI unit of mass is kilograms. So 0.250 times 65 will give us 16.25, right? 16.25 grams. So that is your answer for that. All right. So with that, we have come to the end of today's class, right? So hope you have gotten all the explanation that is given today. All right. Now, please remember to click on the subscribe button so as to come across more educative and enlightening videos. And remember to share this with family and friends. See you in the next class.